Hi, my name is Cher, and I'm going to talk about IP addresses. Well, interesting about IP addresses that it's just numbers, but after today you're going to learn why it's more than just numbers, and you're also going to learn why and how IP addresses correlate to binary numbers. So, some of the important things in networking is the IP address, also known as IPv4. We'll talk about that later. The subnet and the gateway. Now, excuse my screen, I know it's a little bit small, but right here you can see that there is IPv4, and you just move over and you will see it's 192.168.57.61. Now, the IP address is specific to each computer, so this is how people are able to trace you, or how people can identify your computer. Alright, good thing you can actually change your IPs. Now, another important thing is the subnet, the subnetwork. So right here, the subnet mask is 255.255.255.0. This means that these three numbers is going to be a constant because it's 255. So 192.168.57 is always going to be the same. But this 0 means that since this is your network, this is your network, this is going to be your host. Your host is interchangeable. So this number can actually be 62, 63, 64, or anything all the way to 260 or to 255. And that is what your IPv4 address and subnet mask has in common. Your subnet mask tells you what IP address you can actually use. So if this was a 1, you can use 254 IPs. If this was a 2, you can use 253 IPs, so forth and so on. Now we have your gateway. What your gateway tells you is that this is how you get out to the World Wide Web. It doesn't just go from your computer to the internet. It goes from your computer to the default gateway, which is most likely your router, to the internet. So not computer internet, it's computer gateway internet. Now, some of the commands we're going to do for today is ping and NSLOOKUP. For ping, what we want to do with ping is find out the name of the website and the IP address that correlates with the website. So as you can see right here, I say pingyahoo.com right here, and this is my response. So I get 3 replies, which is a good thing, and it all gives me back the same IP address. That means the site is working for you. Let's say you only get 1 reply, and then you get some error, and then you get a reply again, and then you get another error. Then you know that something is wrong. But right now I can ping Yahoo, I get multiple replies at the same time, website is good. Now let's say I want to know what other IP addresses yahoo.com has. Well, NSLOOKUP, your name system lookup. So this is the name, this is the system, and we're going to look up the IP address. So right here you see that I use NSLOOKUP yahoo.com. So I'm looking up the domain name, which is Yahoo, and this is my result. 3 different IPs. But look, 98.138.253.109 matches with this. So if you went on the internet and you enter any of these 3 IP addresses, yahoo.com will show up. Funny thing about ping is that if you ping once, it helps you look up an IP address. But if multiple people pings your computer, well, according to Greg White from Security Plus, if you get multiple pings, this is what is known as an attack, and this can actually crash your system. And the last command we want to learn about is traceroute. Basically, traceroute, what it does is that it traces where your computer is actually going to from the computer to the website. It traces every place that it hops to. So let's say I want to trace route yahoo.com. The 192 is my computer, and this last line 14 is yahoo.com. So it hits 13 different computers before it finally goes to Yahoo. It's pretty crazy. So if it stops at number 8, then you know where the issue lies. Now we're going to learn how to read binary. Why does IPv4 have 32 bits? Well, we're going to just look over here for a second. Hey, look. There's 8 ones here, 8 ones here, 8 ones here, 8 ones here. Each one represents a bit, and this is why we have 32 bits. But why is that? We'll learn about that later. Now we're going to learn how to translate IP to binary. So you can see that 8 bits is 255, 8 bits is 255, 8 bits is 255. So if you get 4 8-bits, that's how you get 32 bits. And according to Greg White, writer of Security Plus, each IPv4 address uses 32-bit space. Now we're going to teach you why that is. So we're going to learn how to translate. So these are the IP numbers, and these are the ones and zeros. As you can see, 1 equals 1, 2 equals 1 moves over to the left, add a 0, 3 equals, add a 1, 4 equals, 1 moves over to the left, everything turns into 0, 5 equals, add a 1. So you can see that that is how we translate IP to binary. Now there's actually another way you can do it, and we're going to learn how to translate binary to IP. Boom. Scroll down a little bit. Sorry about the big screen. So I create a little map for you. So let's say that this is our binary. There is 8 ones, but how come 8 ones is 255? Like we said earlier, how come 8 ones mean 255? Because if you add up all these numbers together, it turns into 255. So each number, each bit has a number. So let's say we don't want 255. Let's say we want 20. Okay, let's make 20 a little bit bigger, shall we? So let's say we want 20 instead. What plus what is 20? 14 or 16 plus 4 equals 20. So we'll get 1 bit to 16, 1 bit to 4, everything else turns to 0. Now let me just make this a little bit bigger for the audience. Okay? Now let's say we don't want 255, we want 254. So what can we do? Well, simple. We just subtract a bit, because 255 minus 1 is 254. So everything will be 1, except for this would be 0. And if that was to change, this would be 254. And that is how we turn binary to IP. But what if we run out of IPs, you ask? Well, guess what? IPv4 will turn into IPv6. That way we can get more numbers, more IP addresses, and more websites. If you can understand this, this is actually very challenging and very complicated in 10 minutes. So if you get this, you might want to take more IT classes, and maybe you may want to actually change your career. And that will be my presentation for today. Thank you.